It's no secret that NASA wants to return to the moon, and this time the space agency wants to do more than just observe and collect samples. At the very least, NASA wants to set up a permanent base and even mine the minerals underneath the lunar surface, just like we do on Earth. But is that even feasible? And what are the legal and safety consequences that come with mining the moon? Having completed an approximately 1.4 million-mile journey from Earth to the moon's orbit, the Orion spacecraft completed a successful splashdown in the Pacific Ocean on the 11th of December, 2022. It was a historic event, given the circumstances that preceded its launch, and understandably, the internet and tabloids cannot seem to stop talking about it. Artemis's first mission is just a taste of what is to come. And we dare to say that as NASA continues to achieve new milestones in its Artemis mission, the public can expect more and more things to talk about. Especially if we extend our habits of digging the depths of the ground to the lunar surface. But logically, the first question we should ask ourselves is, are there minerals to mine on the moon? Well, scientists believe there is. In fact, thanks to the amazing work of the Clementine spacecraft, we've found hard evidence about the existence of water ice on the moon as far back as 1994. This was about 2 full decades after the Apollo mission, so you can imagine that scientists would be scrambling to explore this water ice from close range. The discovery of water on the moon changes many things for us in space exploration, especially because it gives us an extra option for sourcing water in space. Indeed, scientists have been able to source water for use on the International Space Station through different advanced recycling techniques. Some of these methods could actually work on the moon because they are not only effective but also very efficient. But the ISS is quite small in the scheme of things, compared to the proposed moon village that's in the works. On average, the ISS houses between 3 and 6 people, and according to the fact sheet, the most number of astronauts that have ever been in the facility at once is 12. Obviously, we expect that the moon village or any human settlement on the moon will have an average population of about 50 and 100 people, which means we'll need more water and more water sources. If this should happen, transporting water from Earth to the moon would be incredibly difficult, just like our so-called advanced recycling process. That leaves us with only one cynical option, which is to mine water. If we are able to do this successfully, it would be a big achievement for scientists and humanity at large, because in the end, the water generated can be used for many purposes, including generating energy and fueling our space rockets. But how do we get this water from underneath the lunar surface? Over the years, scientists have been developing the technology that will power their dream of mining water on the moon. Recognized technically as in situ resource utilization, this technology is designed to facilitate the mining and usage of natural resources in space. One element that we might not need to mine is oxygen, because it is relatively abundant. For perspective, every natural mineral on the moon contains oxygen, but the same cannot be said of hydrogen. But interestingly, we need hydrogen to free up the oxygen that's locked up within the minerals on the lunar surface. For instance, if we subject items like ilmenite and titanium to extreme heat of around 1000 degrees Celsius and mix them up with hydrogen, water is produced. Of course, the water could be electrolyzed into hydrogen, which is recycled, while oxygen is effectively liberated from ilmenite. However, extracting hydrogen from water could be dangerous for future generations because the process isn't exactly sustainable. In other words, mining water from underneath the lunar surface might destroy our grand plan to set up a village on the moon. But that's not the only issue we are going to be dealing with. Aside from the difficulties involved in mining water on the moon, the mining location is quite tricky. According to scientists, the water on the moon is located around the deep craters, which are hidden from sunlight. Hence, the temperature around the area is around minus 233 degrees Celsius. This automatically means there is an almost 0% chance of generating solar power in the region. And as far as we know, scientists do not have ample experience conducting extensive mining activities at such frosty temperatures. But thankfully, there might just be a solution. In another region of the moon around the South Pole, scientists have found peaks of eternal light that are exposed to sunlight at a near constant rate. Interestingly, scientists believe there might be a way to reflect this sunlight from the South Pole to the deep craters using supergiant reflectors. In fact, scientists at NASA's Jet Propulsion Lab are currently working overtime on developing this technology and the components that will facilitate it. Expectedly, the mirrors will be constructed on Earth before they're transported to the Moon. But once they're installed on the lunar surface, scientists will be able to control them remotely from the comfort of NASA workstations here on Earth. Once they begin active service, the mirrors will help to illuminate the deep craters, while robotic mining devices can explore the crater and mine water using the solar power generated by the reflection of the giant mirrors. Furthermore, the water ice can be directly melted into vapor for recovery by direct thermal or microwave heating. Obviously, this would consume a lot of energy, but don't panic, because solar energy is an incredibly abundant source of power. Alternatively, the water ice could be physically dredged out and subsequently melted at reduced temperatures. In any case, water as we know it here on Earth is more useful when it exists as a liquid, especially considering that we'll have to store and preserve it for a while, perhaps even for months. Oxygen, as we know it, can be liquefied easily at a temperature of around minus 243 degrees Celsius and a minimum pressure of 15 bars. However, liquefying hydrogen and maintaining it as a liquid without boil-off would definitely require additional energy, which again wouldn't be a problem as long as we're able to utilize the solar energy on the Moon. In addition, the cryogenically cooled hydrogen and oxygen must be transported from the mining spot to its final destination on the Moon in containers with low temperatures. Currently, NASA has plans to transport astronauts to the lunar South Pole by 2025 through the Artemis mission. Similarly, the prominent space agency is launching a special rover mission called Viper by 2023. The said spacecraft will help map out the lunar ice deposits around the South Pole. According to reports, 3 American universities have been awarded different contracts to develop various technologies for the moon mining project, to the tune of around $2 million. But it's way more complicated than it sounds. To begin with, this fascinating anticipation must be matched by some outstanding technological breakthroughs, especially as regards space exploration. Otherwise, the plan would be more or less dead on arrival. Secondly, law experts argue that NASA does not have the liberty or permission to mine on the Moon or any other planetary world outside of Earth. Sounds unbelievable, right? Well, sure it does. But many decades ago, during the Cold War, the United States and the Soviet Union took their rivalries to the realm above, and seeing the dangers that this could pose to the entire human race, world leaders, including the United Nations, rallied to convince both to sign an agreement that states that no country can claim sovereignty over any planet beyond Earth. In all, more than 100 countries put pen to paper. And as far as we know, it has not been changed, updated, or canceled, which means it is still valid. And NASA may have to fight it in court if they're really serious about mining on the lunar surface. Aside from water ice, scientists are optimistic that we could find yet other elements underneath the Moon's crust. When we go to the North or South Pole and we actually start mucking about with the regolith, we may find some things that the Apollo missions didn't. But from a very large perspective, we think we know what to expect, NASA engineer Jerry Sanders said during an interview with UPI. Which elements or minerals do you think they will discover?